Hello everyone, I am K. Purushottam from second year data science from SVCE Bangalore. Friends, do you all know what to do when there is a problem and to get a solution for the problem? We need to try many ways. Finally, one of the method will give us the solution. For example, solving a Rubik's cube or a magic cube, etc. Such issues are solved by straightforward algorithm technique, which is called brute force. It symmetrically tries all possible situations. I hope you got an idea about brute force. It is an algorithm and this works by trying all possible situations. There are simple to understand and implement but can be computationally expensive. The following approaches are these. First is executive search. This approach considers every possible situation, ensuring that optimal solution is found. Second approach is symmetric approach. This approach, in this approach, brute force algorithm follows a predefined structure systematically exploring all possibilities. Third one is Naive solutions. They represent the most basic approach to solve a problem. This can be a starting point for more effective algorithms. Let us try to see what are the characteristics of brute force algorithm. Simplicity. It is very simple and easy to understand and implement. The involves straightforward steps by procedures. Comprehensiveness. They guarantee that all the possible situations can be explored, thus ensure that optical solution is found. Inefficiency. They can be computationally expensive, especially for problems with large input size, and they consider all possibilities. Next, moving on to some examples of brute force. Sort, bubble sort are the examples which work by repeatedly comparing and swapping elements in an array. Selection sort repeatedly finds the minimum element in the unsorted pair and swaps it with the first element of the unsorted pair. Bubble sort. Bubble sort repeatedly steps through the list, comparing adjacent elements and swapping them if they are on the wrong order. Sequential search. Sequential search is a brute force search algorithm which linearly travels a list comparing each element to the target value. First, start at the beginning and search the first element of the list. Second, compare and move, where each element is compared to the targeted value. It matches is not found, it moves to the next element. Third one is repeated until found. The search goes on in a sequential way until the target value is found or it reaches the end of the list. Cryptography, optimization, and pattern recognition are three most commonly used applications. In cryptography, all possible keys are tried to decrypt an encrypted message. Optimizing initi- Optimization includes finding the optimal solution by evaluating all possible combinations. Pattern recognition includes matching a pattern in a data set by comparing all possible combinations of elements. Now moving on further, let us discuss about time complexity of brute force algorithm. It is determined by the number of operations they perform, which depends on problem size. Linear time. Here the time complexity is big O of n, where n is the size of input. Exponential time. Algorithm like brute force encryptions, the time complexity can be exponentially, which can be very slow for large values of n. Polynomial time. Algorithms like bubble sort have a polynomial time complexity, making them less effective for large inputs. Space complexity of brute force algorithm. The space complexity of a brute force algorithm to the amount of memory they require to store data execution. Constant space, linear space, and exponential space. Constant space. Some algorithms like sequential search require a constant amount of memory regardless of the input size. On the other, sorting algorithms may require additional space to store temporary data proportional to the input size. Exponential space. Algorithms that store all possible solutions, such as brute force encryption, can have an exponential space complexity. Optimization technique for brute force algorithm. While brute force algorithms are often insufficient, there are optimization techniques that can improve their performance. Purine. This technique involves elements unlike solutions earlier in search process, reducing the number of operations performed. Reprocessing the input data can help optimizing the brute force algorithm by organizing the data in a way that makes it easier to search. I would like to conclude this topic by saying that brute force algorithm offers a straightforward approach to problem solving, but their inefficiency can be a limitation. Time complexity. Brute force algorithms often have high time complexity essential for large inputs, making them unsuitable for real-time application. Space complexity. Storing all possible solutions can lead to significant memory usage, particularly for problems with large search space. Thank you for joining my session.